Hey students, so today we're going to be filling out your seasons notes. So what you're going to do with this page is you're going to start right here with July, and basically what you're looking at is you're looking at a setup of how the earth looks as it travels around the sun. So you'll notice that each one of these earths has an axis, and what I want you to do is draw in your equator on each one of these and indicate whether the southern hemisphere and the northern hemisphere, okay? So we'll start here with July, and we're just going to continue counterclockwise around the sun. The next month after July is August, and then we have September. So in September we have a pretty significant event in the orbit of the Earth, and what happens is when the Earth moves into the plane of the ecliptic. The plane of the ecliptic is basically the line, this imaginary line that we have that shows the direct sunlight and where it hits on planet Earth. So in September, the direct sunlight is hitting right here on the equator, okay? So we have what we call the fall equinox. And we're going to write a definition up here above for what an equinox is. So the equinox literally means equal night. Okay, an equal night means that, so equal night, an equinox, is when we have the point in the Earth's orbit where the equator is meeting up with the plane of the ecliptic. So the plane of the ecliptic is kind of this imaginary line that shows us where the most direct sunlight is coming out from the sun, okay? So the September equinox, the fall equinox, usually happens around the 21st. After September, we have the month of October, and then November. And then in November, we have so in December, we have another significant event happening in Earth's orbit. So we're going to draw our axis in, and then our equator again right here. And this is our northern hemisphere, and here's our southern hemisphere. And if we use this line to draw all the way over to planet Earth, we see that the direct sunlight from the sun is hitting the southern hemisphere at a 90-degree angle, and we still have sunlight in the northern hemisphere, but it's just at a different angle, so we don't have as warm of temperatures. And this event in December, when we have that highest point in the southern hemisphere, in the north we call it our winter solstice, S-T-I-C-E, sorry about that. And in the southern hemisphere, this would be their summer solstice, okay? So the definition of a solstice is the point in the Earth's orbit when the sun is at its highest or lowest point in the sky. Sorry, that's really squishy there, okay? So that's a solstice. Then we fast forward into January, to February, and then to March. When we get to March, we have another equinox event. So this is the spring equinox. Okay. And then it's the same thing that happens up in the fall. We have the plane of the ecliptic passing through the equator, but this time we're just on the other side of our orbit. So this is where our spring starts. Then we move on to April, May, and we get back over here to June, where we have direct sunlight hitting the northern hemisphere instead of the southern hemisphere this time. So our direct sunlight is hitting right here. So that plane of the ecliptic is hitting right here in the northern hemisphere. So this happens around June 21st in the northern hemisphere. This is our summer solstice. So this for us is the point in the year when we have the sun at the highest point in the sky. And over here at the winter solstice for us in the northern hemisphere, it's the point where we have the sun in the lowest point in the sky. So this just kind of walks you through the different seasons and why we have seasons. So one thing I want to make sure that you understand really clearly is that in December we are actually closer to the sun, which means that distance from the sun is not the thing that affects seasons. Distance from the sun has no effect on seasons. Our seasons are affected by the direct sunlight that we get during that particular season. In June, you'll see that we are farthest from the sun, but that's our warmer time of the year because we're getting more direct sunlight. So hopefully you've already done the indirect and direct sunlight lab, and that will have shown you that the more direct the sunlight is, or the more direct light is, the higher the temperature gets.